Okay, we're now going to be talking about the graph modeling question number 8. Take a minute to pause and read this question. All right, now that you guys have read this question, we're going to talk about it. So the question basically tells us that there's two people, Frodo and Sam, and they're on their way to this village called Mordor, right? And they have to pass through several human villages. And we know like they have some information, additional information, such that they know that some of these villages are deserted, and these deserted villages are likely orc territory, and it's mostly like heavily guarded by orcs. So we want to avoid these territory, right? So we want to think about how we can represent this problem in terms of vertices, edges, directed, weighted, and so on. So just thinking ahead, like in part B, we will be finding the shortest and the safest path for Frodo and Sam to go to Mordor. So we just need to think about that, and we need to think in a way that our graph model needs to support that. So how would we represent a graph to capture this problem? So let's start by breaking down this question into key bits of information so that we can encode this information in our graph. So we need to travel to Mordor. So we need to pass through villages. That's our first one. Second one would be our villages could be occupied or they could be deserted. And we know this from the question, right? The third one is certain roads to villages could be monitored by dangerous orcs. So certain roads, we kind of want to avoid these roads that are monitored by dangerous orcs. And yeah, so the fourth point basically says that avoid these roads between two deserted villages. These are likely to have orcs. So our design could be something like we could set the vertices to be villages, and edges could be the roads between villages. Vertices can store information whether a village is occupied or deserted. And we will need this occupied or deserted to avoid these roads between two deserted villages. So again, we can have an undirected graph because we want our two people, Frodo and Sam, to be able to walk back and to and from the villages. And it could be unweighted because we already capture our deserted or not deserted information in the vertex. So we don't need to capture any additional information in the edges. We will also allow parallel edges since there may be many different roads connecting two villages. Also, there's going to be no self loops since they are not useful in any way here. All right, so moving on to question B. How would you find the shortest and safest path to Mordor? So let's think about the shortest path algorithms that we know. So we know two algorithms, right? We know we know BFS, and we know Dijkstra's. Since Dijkstra's was mainly for weighted graphs, we could run it on unweighted graphs, but BFS would be more efficient over here, and that's why we choose BFS over Dijkstra's. Safest path algorithms. We don't recall doing anything of this sort in the class, so we need to like modify our current algorithm to make it safe. So let's think about how we can do that. What does safe really mean in the context of a graph? Right. So remember that the friendly spies, they told Frodo and Sam to avoid the roads between two deserted villages. So if we are not going on any roads that are connecting two deserted villages, that's considered like safe in the context of our graph. So the shortest path would be BFS, and then for safest path, let's see how we can do it. So one way that we can do it is we do some pre-processing on a graph and we remove these edges. So this way, when we find the shortest path, Frodo and Sam won't be able to take the dangerous roads. So essentially what we're doing is, suppose you have a graph of like 5 nodes and there's an edge in this graph which connects two deserted villages. In our first pass, we just take out this edge. So the next time we run BFS, this the edge between two deserted villages won't exist. So it'll find the shortest path without having to go through that road which connects two deserted villages. So our safest path algorithm would be a modified BFS. We modified it to make it safe as well, since BFS will give a the shortest path on an unweighted graph. So the solution would be to run the BFS once to remove all the unsafe roads and run the BFS again to find the shortest path. And the runtime of this would be the runtime of BFS, which is theta of V plus E.